Hi, it's John Williams from MIT here, and we're looking now at climate data. So this is a very practical application, and this is real climate data that we're going to plot in Google Charts. So let's go take a look at the data first. And the data here is in, let's load this file, climate data. And if you go to view and word wrap, that's much better. So here's the climate data, and it's various sources. And here GISS, for example, is one source. HAD stands for Hadley. This is National Oceanographic and Atmospheric, NOAA, and RSS and UAH. So there's quite a bit of data here, and it dates from 1880 January onwards. Okay, so oops, I made a change there. Okay, so we're going to have to use pick up dates, and we'll choose one of these. We're going to choose GISS since it runs all the way up to 2011. Okay, so we've already seen how to handle big data like this when we looked at Boston City data. Yeah, remember, here was Boston City data. So now I'm going to look at climate data, and I'm calling it climate data regression because we're going to draw we're going to do a regression analysis on this data and find a line that's the closest fit to these data points. So let me just show you what it looks like. So here's the data from actually there's some 1878 in there, 1880. Okay, and we go all the way up here to 2011. And then we're going to draw the best fit line to it. Okay. So let's take a look at the code. And so how do we load the climate data? Well, we've already seen that. We just put a script tag in there and specify the file name. And I've already got JSON data. Let's have a look. And if I look at the top of the file, I'll see what it's named. Okay, and it's good old data again, var data equals. And this time it starts as an array. You can see by the angle bracket, and inside are objects. Okay, so that's an object, and it goes all the way up to there. Okay, so let's load that data, and we'll break in and take a look. So here we reload it, and I'm going to bring up the development environment. Let's have a look at climate data here. And let's scroll down, generate data points, and here we go. So if I break in here, we should have the data loaded. Let's load that again, and here we are. So we should have something called data that's already loaded. Let's have a look. Somewhere here I'm going to reference data, I think. Data, there it is. So we've got 1,574 points, and if I look at data, it's an object inside, and this time the readings are all these. So to pick it out, we're going to pick out one of these, the GISS one. Okay, so since it's an object, it's going to be a little different to what we did before with the Boston City data. And here's the date. We're going to have to change it to year and month. Okay, so let's see how we do that. Well, we can pick out of the data the date. Let's just check that we've got that. So data, and we're going to go, and date should pick us a date. Yep. Data 0 dot and GISS. Yep, that gives us an anomaly. Okay, so this is minus 0.41 degrees. So we can definitely understand the data. Now let's take a look at some of the things that we need to do. And let's take a look here. We've got Boston City data, and some of the things I'm going to need. Oops, sorry. I need climate data. So, generate data points. This time our data set, we're going to start with a date and a temperature. And that's going to be a number. The type will be number actually on that. I could add that in there. Let me do that. So, comma, type, colon, number. Okay, that's still correct. And now what I've got to do, I'm going to pull out the date, and it's of this form, 1891-01. But I believe it starts at 00, so we've got to be a little bit careful. So if I divide that number by 100, I'll get, and do math.floor, I'll get that number. So that'll be the year. And now I'm going to pick off this part. So the month is the whole thing, D, minus the year times 100. So basically I'm going to subtract 1891.00 from whatever number I get, and that'll be my month. Okay, but here we'll see that they're zero basing the month, so January is 0. So for date, January should be 1, and here I'm putting the first day for all of the dates because it doesn't give us that, but we need to use this constructor to construct a valid date. Okay, so, and then we create our data set by pushing in the date, and we're going to round this to a number, this GIS, whatever it is, and rather we're not rounding it, we're making it a number in case it's a string in the data. Let's have a look at the actual data. Is it a string? Yes, you see it here, it's a string. So that's why I need to create it, make it a number. Now we've got our data set. And now the draw options, we just do the draw chart typically. We're going to pass it the data set, and down here we'll do array to data table, and then we'll just pass that data table to chart.draw with these options. Now the options are interesting. We're going to do a scatter plot just like we did before, but this time we're going to do a trend line. And what this does, this is quite amazing. This fits the best polynomial, and here we're specifying degree 1 to the data. And this says, I want to show a measure of the fitness, how well that line fits the data. So what I want you to do, so this is, I'm going to save that, and we'll run it again just to make sure we're good. And let me get out of the I seem to be paused in here. Let me get out of that. And it says that the fitness of the data is 0.65, which is pretty good. So here we've got our dates, beautiful dates. And here we've got the anomaly. It goes from not quite -1 to 1. And we've got a pretty good fit with this line. So you should be able to predict what the temperature will be in the future from this fit of line. Why don't you predict, based on this, what the temperature would be in 2025? Okay, so what will the temperature anomaly be in 2025 if we keep it, if we believe that the temperature is rising in a straight line? Now, of course, it may not be rising in a straight line. So let's maybe do a fit degree 2 to the data. Now, and let's run it again. There we go. And now, we had this with a fit of 0.695. So 2 doesn't give it a much better fit, actually. Now, you've got to be careful. If I go to higher and higher degree polynomials, we're going to get very wiggly lines. Let's see if we can do one of degree 4. See what it looks like. Should be a better fit. Oh, but it's looking quite crazy here. And the fit was 0.728. The fit is bound to be better, the higher degree polynomial, but it doesn't mean you're necessarily predicting better. Okay, so let's change this back to 1. And why don't you, let's do an exercise. Let's do a prediction, right, based on this straight line for 2025. So there we are. Go out and find exactly what the value will be in 2025 for the anomaly. Okay, bye for now.